another example now. Okay, so we're going to look at another example for BJT amplifier analysis. So here we've drawn a common collector amplifier. Note that it's a common collector because the input is on the base and the output is on the emitter, and the collector is grounded relative to both of those. Sometimes they call the common collector amplifier an emitter-follower. You'll see this used in the textbook and online often. Now, we're going to go ahead and try and go directly from this schematic to the small signal model. We're going to short the big capacitors, short the DC voltage sources. Okay, we can see that R1 is connected to between the base and ground. We have the VBE, or R here. For the emitter, we have a resistor R sub E that goes from the emitter to ground. We have a resistor R sub L that goes from the emitter to ground. We note that the emitter is tied directly to the output voltage after making our substitutions shorting the big capacitors in the drawing above. So we can now write a KCL expression at the output. E out times 1 over RE plus 1 over L plus 1 over 0 B out minus Bn over R pi is equal to GM VBE. Okay, we know a couple things here. VB is equal to VI, VE is equal to VO. Now again, we're going to go through a bit of algebra here. And in the end, we solve for V out over sub pi, the voltage gain, 1 plus GM R pi divided by R pi times the quantity RE parallel RL parallel R pi divided by plus GM times that quantity. Now, it's important to note that the numerator and denominator are going to be approximately equal to one another. And if this is the case, then we can say that the voltage gain is approximately equal to 1. We note that this is a common collector amplifier or an emitter-follower, and we expect the voltage gain to be less than 1, but approaching 1 if we design it well. So we'll stop there for this video, and in the next video, we're going to look at the input and output resistances and how to find them for a few different amplifiers.